Okay.
Okay, we're going to go ahead and start the lesson. Talking about pipeline scientists. And I know that a number of people in this room have had their code reviewed by Mike and learned a huge amount through that process. And so he's going to share some of that so that you can potentially do reviews as well and respond to reviews.
Great,
Okay,
thank you.
thanks, Mike.
Yep. So thank you. Okay, so I've given a couple. This is probably too high. There we go. That's probably better. You still hear me? Sounds like. So I've given last time a lesson on writing unit tests. This is going to be kind of a different aspect of ensuring that your code is good enough. So the question, how do you know if your code is good? So aside from code reviews, what are some ways that we have of knowing whether our code kind of is good in whatever that sense means? Who has ideas? Yeah. Sorry? Oh, PEP8, right. So you can run linters on it. Good. So this is a good way to check that your style conforms to some standards. PEP8 is a good style standard for Python. Good. Coverage tests. Good. Yeah. So once you have some unit tests, you want to know whether your unit tests cover all of your code base. And code.cov is a good one. Not you're covering all of the parts of your code with some unit test. Excellent.
So that whole coverage thing seems sort of magical to me.
Yeah.
I kind of understand at some level how it works in Python. If you're writing C++ code, is there an equivalent?
Yeah.
So somehow it actually is analyzing your code base to try to figure it out yourself? I mean,
Yeah.
Python is somehow doing some sort of self-introspection.
Yeah. So his question was basically how does that work behind the scenes? I'm not an expert in that. So in Python, it does kind of keeps track of which lines of code get touched. C or C++ or Fortran compiled languages, it's harder to do that. But there are ways with compiler flags to you have to basically recompile it with a special flags, and it'll it does something with the -G kind of stuff, like all these debugging things, and it can keep track of kind of which parts of your code get hit. I'm certainly not an expert, but bug grind people and things like that have solved it. Okay, so the kernel ptrace apparently is relevant here. You have to compile it, yeah, but you can use the same tool. So code.cov and coveralls can look at that output. Grind 2 is a good one. Yep, good. All right, code coverage. Anything else next? Somebody? No one has other ideas? What? To somebody, good, yeah. So that's what we're mostly going to be talking about is like let someone else look at your code and critique it. So that's good. So that's most of what this lesson is going to be about. So nobody mentioned kind of the most obvious, I think. The thing that you're probably all doing already is just try it out, run it, right? Run your code on some bit of data and see if the output looks right. In fact, I would argue that for small scripts that are making a plot, that's entirely all you need. Right? Is your code any good? Does it make the plot the way you wanted the plot to be made? Right? So the color's right. Is the thing, the reference line in the right spot? You can just tell by eye whether your code is working by what its output is on really simple stuff like that. So that's don't discount that. That's a very valid way of checking whether your code is good. Tests, we've talked a little bit about that. So the tests in general, coverage of the tests is a part of that. Having a good unit test suite and integration tests, things like that. All the stuff I talked about last time are an important component of telling whether your code is any good. And then finally, I think the third big one is code review, which is what I'm going to be talking about. So what is a code review? So a lot of you maybe, so let's have a show of hands. How many people have participated in a code review, either submitting code to be reviewed or reviewing someone else's code? Looks like more than, about half to more than half. Okay, good. So what's involved? So the basic procedure is a lot like actually submitting a paper a scientific paper for peer review. The process is not too dissimilar from that. So you submit your code through some mechanism. So GitHub is one that I'm going to be using a lot as an example, but it's not the only way. But you submit your code in some form for people to look at. One or more reviewers will look at that code and make comments, suggestions, accolades, whatever. You ask for some modifications. Scientific paper referee reports, right? Even if you think it's a great paper, there's almost always, well, I think this plot shouldn't, could be tweaked a little bit, or maybe you could rearrange these sections because I think it presents weird this way, and this way it would be better, whatever. So the same thing with your code. You can say, I think this API is a little clunky, you should redesign it this way, or I think you don't have a test that covers this corner case, things like that. So you make some kind of request for modifications. The developer then responds, and again, just like in a scientific referee response, you can either say, oh, yes, you're right, you're the magnificent referee, and I bow to your intelligence, I will make those changes. Or you can say, no, I respectfully disagree, I think that this way is actually better, and here's the reasons why, blah, 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 blah. Same thing here, you can make the changes, or you can push back and say, no, I thought about that, and I tried it that way, and it didn't work because of this, this, and this. Both responses are completely valid. And then once the reviewers are all satisfied, through whatever mechanism your group decides satisfaction, then the code gets merged into the main code base, and it becomes part of the mainline code. And so I am a fan of using GitHub for all these steps. GitHub makes a lot of this very easy. Bitbucket is another one that has similar stuff, and there's others beyond that. I'm going to focus on GitHub, but don't imagine that's the only tool for doing this stuff. All right, so just going to kind of walk you through for those of you who haven't ever done this. Good. Okay, so this is the GitHub pull request page. So all my examples are going to be from Galsim. As many of you know, I'm one of the developers of Galsim, so I have lots of examples of pull requests and code reviews in Galsim. You'll see a lot of examples from that. So people who've contributed to Galsim, Josh appears frequently, Rachel, who's I think not in the room, but people who've contributed. This is our current page for pull requests. If you want to make a new one, you would click this button, New Pull Request. And it'll open up a page where you say, what do you want to compare? So you'll have your new code. So let's say we go to, so this will be the next one that Josh will probably do in the next few days, is this 2kick. So it's a branch he's been working on some new stuff. And we actually don't want to merge it into this one. We want to merge it into master. And you can see here's a whole bunch of commits, right? And here's his, here are his changes, right? You would click Create Pull Request. And that opens up a page where you can describe what you did. So you give it some kind of title. 2kick, it'll use the name of the branch as default. You should change that to something like, add the second kick to the atmospheric TSF, whatever, right? And then you leave some comment giving more detail. So I did this and this. I added, the second kick with the von Karman profile, blah, 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 whatever, right? You describe what you're talking about. And then it shows here all the files changed. So you can look through what the code changes are. And once you click Create Pull Request, which I'm not going to do because I don't want to actually make that, it'll look like this. This is the previous one. So here's his description. So this PR adds a von Karman profile. It does all this, talks about a surprise I encountered, right? And we can click here to see the files changed. And as a code reviewer, what you would look through this, it only shows the new changes to it. And you might make a comment here saying, really? Oops. 11.6? Whatever. And Josh will say, yes, dummy, it's 11.6, right? So you would start a review, right? And so it doesn't actually email this out yet. and you see it says pending. So you go through and you add all your comments, you know, you can say like, oops, lost connection somewhere. Hello? And apparently you guys are going to see pictures of my kids every time we do this. I have to move that over again. That's annoying. All right. Okay. I'm not sure why it keeps dropping that. Can I make it bigger? Oh, yeah? Okay. I can bump it up a little bit probably. There we go. That better? Right. So you can say, you know, change this to freed, right? Right, something like that. And you can keep adding review comments. I don't actually think either of these comments are appropriate to say, but I'm just giving you an example, right? So you know, you would add all your comments, and then when you think you have everything done, you have up here, it says review, and it says there's 2 changes that you've made so far, 2 comments you've made. So you click review, and then you can add some summary. You can say, this is great. Chris has been waiting for this. And DC2, whatever, right? And then you can either approve if you think it's all good. Even if you have changes to approve, you can just assume that they're good. Like sometimes you'll do this with a paper. You know, approve, but here's some changes you might make that I think could improve it. But I think this paper is great, and recommend to the referee, recommend to the journal to accept the paper. But you can still have some comments and requests, right? That's perfectly valid. If you basically want to see the changes after they're done, then you would do request changes. This is equivalent to in a referee report saying, you know, no, I think, you know, there's significant changes that need to be made, and after they've made them, the journal's going to send it back to you as a referee to check. So that's kind of the model you can have in your head. If you're not really wanting to make a decision one way or another, you don't feel like you're have the expertise, you're allowed to just do comment, and it won't count as a review one way or the other. Yeah, maybe you just had some questions as a user, and you don't feel like you're really reviewing the code, but you still want to make comments about it. There's an option for that. And then you click Submit Review, which I'm also not going to do.
I never did the step where I started reviews, so I'm probably going to be taking too much email or something. I just somehow just been clicking plus each time. So can you do that start review if you haven't been assigned as a reviewer?
Yep, anyone can. I just started it from scratch here. Yeah, so I don't think I've been officially assigned. Okay. Now let me go to another one. So this is now a real review with real comments and a completed process. This is one that Alex submitted. And so you can see here's his description. And so let's look, so you can view, so this is kind of looking back in history. This is what the changes looked like when he first submitted them that I responded to. And so here's how it shows up after I hit submit review. This is what Alex will be able to look at, or was able to look at rather. So he sees my comments, and he can then add a reply here saying, you know, oh, you know, I actually meant to do that, or whatever. Yeah, you can reply. Alex, as it turned out, I don't think replied to any of them, although you see Rachel, you know, +1 one of my comments means she agrees, obviously, right? She has some of her own here.
I think we were sitting next to each other at the time.
Probably, yeah. So he probably responded verbally rather than, which is fine. So yeah, and so this one, you know, I blame myself, or one of them I think I said is my fault. Anyway, and I go down here, so a bunch of code. Here's some his unit tests. I say the error message is wrong. He accidentally did a copy paste and forgot to change something. Right, and so he mentioned that he thought it would be worth having some particular test, and I say, yeah, you yourself mentioned this, and I agree, you should add this test, right? And he goes back and go back to here. Now, this is after the code review. He's submitted more commits that make these changes. Rachel says, all looks good. I think I have one more comment that he made, and then boom, and then we approved, and it's all done. So that's the full-on completed process. Yeah,
So when you
correct.
make those additional commits, it's still the same pull.
Still the same pull request. Yeah. So they add it to the branch, and until it gets merged, they show up as part of that that code review. So the reviewers can go back and look and see exactly what the changes are, and when they're happy, they. So the thing I didn't show here, I guess. So the first time I didn't accept, I hit request changes, and once it's all done, I can say accept changes, and there's a little button that shows up. It's no longer there, of course. I've already clicked it, but I can click accept changes, which now turns that request changes into an approve. So that's kind of the process of doing code review on GitHub. Any questions about that or more comments? Yeah, Andrew. Well, this was during a hack week, so I think the entire process of Alex starting the job to submitting the pull request to being reviewed to being accepted was 3 days. That was, so my role of that of doing it was probably half an hour, I would guess. I don't know how long Alex spent doing the code. Probably most of 2 days, I guess, right? Something like that. So this was a main project that we had at a hack week, and it was done, started and finished and completed within a few days.
I'd never touched Galsym before this and have not touched it since.
That's true. And yet we're still very happy to have gotten this pull request. It's good.
Sorry, why is there still a pull request?
Oh, it's closed. So it's, yeah, I guess I could show that. So if we go to, it's not one of these three. So if I click to closed pull requests, these are all the things that now have been done, and it should be in here somewhere. I forget what number it was, but anyway, one of these is maybe the next page. We have 13 pages of these, the closed ones. So yeah, so it's marked as a closed pull request. It's, yeah.
You did the start review and then in the end said, I want more changes. When he made more changes and you wanted to make more comments, did that show up as the same review, or did you have to do start review again?
Nope. So let's see. I think you can, yeah, so it didn't add them to my review. It added them as just additional comments. But I'm still marked there as having requested changes. So until I change that to an approve, the review is still listed as requesting changes.
So then going forward, you just make comments, basically.
I just make comments after the first initial one. That's right. Other comments or questions? Okay. Yeah, Andrew. Sorry? Yeah, so this is online. This is the on the GitHub site. Everything is just through the browser. We don't. I mean, there are kind of special stuff that you can use for this. I don't ever use them. I just use GitHub because it works well enough. There are other options though. Yep.
Do you have, so when Alex added that stuff, you probably added some tests, right? So would you as a reviewer have checked out that branch and run the test, or is there an automatic thing?
Good question, right. So so the question was, do I just look at the code, or would I check it out and run the tests myself? Because tests are a part of it. And so one thing that we have going is that Travis will automatically run the test. So if the test failed, Alex would know right away, right? So he doesn't even require a reviewer. Travis will send him an email, or it'll show as marked failure, and he can look at the Travis output and see what the problem was. It's not uncommon for things to work on your laptop and not work in Travis, or vice versa, right? So, so he at least gets that. I can also run the tests, the code and run the tests myself. So a lot of times that's useful as a reviewer, not so much just for running the test, because we have, Travis will do it. I mean, it's worth doing, and I'll talk more about that. But also sometimes just to play around with the new code, right? You might want to just run it yourself on some simple test things just to see how it works and get a feel for what you're looking at. Sometimes that's easier than looking through code to understand things. So definitely checking out the branch and trying it out yourself is part of a typical part of code. It's not a required part, but it's a typical part. Okay, I'm gonna move on. Okay, so now that you've seen what's involved, why do we do these? What's the point of doing code reviews? What are the advantages of doing code reviews? The fact that that's plural means there's more than just one, so anyone have ideas? What does this do for you that the other options, just writing unit tests and trying it out yourself, don't afford you. Yeah.
Sometimes you might have a misunderstanding of what you should be doing. So like you read a test that passes, but you did the wrong thing.
Excellent, right. So you might have done the wrong thing, right? You worked on some project and maybe you misunderstood the question or misunderstood the point of the issue. And so getting someone else to look at it, say, oh, yeah, that's good, but that's not what we wanted, right? We wanted this other thing. That's excellent. That's definitely a good reason. Others? Yeah, back there.
Helps you focus on writing readable code?
Good, right. So if you know that other people are going to, so the answer was focus on writing readable code. So if you know other people are going to be looking at your code, you're more likely to write your code in a style that will be readable. And this is super important because you yourself are essentially going to be a brand new person looking at your code in 6 months later if you come back to it. You know, you're never going to remember all the things that were in your head while you're writing the code. So readability is super, super important for any kind of code that you want to last more than a week. So if it's a long-term code base, and which is most of the things that Desk is going to be trying to develop, you definitely want to write code that other people and yourself can read and understand easily. So that's definitely part of it. Greg, you had one?
I was just going to say, getting a second set of eyes is always good, because sometimes you can look at the same thing over and over and just miss something.
Good, right. So getting a second set of eyes, just you may have missed some problem that you didn't think to write the unit test for it, and somebody else might think of something that you didn't. That's definitely a good part of it. Yep. Improve your coding skills, right? So we'll get into this more, but that's definitely a big one, right? So if you look at, this is in both directions, right? So if you look at other people's code, or if other people are critiquing your code, you'll learn things about good coding practices that you won't necessarily come up with just like Googling and things on your own. Having that interaction definitely will help improve your coding ability. Chris?
Comments might not only be on the code itself, but on comments and describing things. And often you think you've described things well enough in your comments, but other people can understand it. So it can make the understandability much better in terms of the internal documentation of the code.
Good, right. So improving the documentation. So if you don't have good documentation, then your code reviewer will notice that because they don't know what you're supposed to be doing. So they're going to be relying on those docs to know kind of what the point of a function is or what the point of a class is. So if you don't have good documentation, that'll come out in the code review. So these are all good. Others before I go on? Yes, Melanie. Yeah, the bus problem, right? So you don't want to have only one person in Desk know how some piece of code works. So this ensures that at least somebody else has at least looked at that code at some point in their life and has at least some familiarity with it. So increasing the breadth of how many people have some understanding of the code. Good, yeah, Eric. Good, right. So yeah, so everything might work, but it might not be the best way to have solved the problem. And sometimes that's okay. Sometimes we don't need the absolute best way to solve every problem, but having someone else say, I think this would be a lot better way to approach this. Either it's going to be a lot faster, or it's going to be more flexible, or more extensible. Yeah, so comment on improving that is definitely part of it. So these are all good. So here's some of my on it, which you guys had more than this, so that's good. So it helps find errors in the code, and so the errors are multiple things that you guys talked about some of those. And someone mentioned, so I encourage you to be more thorough in the first place. If you're writing, if you know other people are going to look at it, you're going to write more readable code. You're going to be more thorough about your unit tests. You're going to be, write better documentation. So if you encourage you to do a better job in the first place, if you know other people are going to be looking at it. One is that often it helps the code base have a fairly consistent style. It's not, so I'm not a huge you must conform to PEP 8 kind of guy. But it's very helpful to have a fairly consistent style at least. So it doesn't matter what that style is in a code base, but if a group is using kind of very different styles all over the place, that's really jarring to read. So as a reviewer, I've looked at lots of different styles of code, lots of different, from all kinds of different people. It's not that hard to read styles that aren't your own, at least I find. It is hard to read code that keeps switching between styles. So if you, as a reviewer, one of your things should be to kind of just, if you see something where a style is very different from other parts of the code that's already existing, maybe nudge them and say, maybe we should move over to using this camel case instead of underscores or vice versa or whatever. Someone mentioned improving your coding techniques, so that's part of it. As Melanie said, spreads familiarity with the code base. At least 2 people will have seen any piece of code. And one that's somewhat subtle, but I think super important, is all of these things will end up saving time in the long run. Okay? One of the common objections to doing code reviews, though, I don't have time to do a code review. It takes too much time. I have other things I need to be doing. In the long run, this almost guaranteed is going to save the team time. Right? You're going to find bugs sooner. You're going to have, through better unit tests. You're going to save your users time because you're going to have better documentation. You're going to save yourself time by having more readable code. So when you go back and you do have a bug, you're going to be able to understand your own code a lot better. So all of these things are going to improve your code, which will end up saving you time. So even though it feels like you're spending a lot of time doing this, I guarantee it's worth it, even in terms of a time management perspective. Okay, so you guys already talked about some of these. So what kinds of errors are we looking for? And so this I'm going to let you guys kind of break up a little bit, talk amongst yourselves, try to come up with many different kinds of errors, and in particular that code review can find that maybe just writing your unit tests might not have found. So what kind of errors really are we talking about? So I'll give you a couple minutes to think and talk amongst yourselves for that. Okay. All right, let's get started again. All right. Who has some ideas? Who wants to start? Anybody? There's lots of talking. Who's got some ideas? There you go. Harry.
So anywhere where human understanding, I've used the wrong physical constant, I've implemented the wrong formula when I'm doing an integral,
Okay, human understanding. Right. So maybe so this gets into kind of I solved the wrong problem, but like if you use the wrong physics for a particular situation, you did some math or physics problem that you're going to implement, and you screwed something up there. Maybe all your unit tests were exactly correct for the wrong thing that you did. Right. So human understanding of what the problem involves is important. That's good. Another idea. Yep.
Not using existing structures or using existing structures improperly.
Great. So not using the current code base, let's say, properly. So if there's already an existing structure that could have been used, correctly, I guess. Right. So not using the existing code correctly or at all is something that definitely the unit tester is not going to notice because it's going to work. But in terms of code reusability, you want to be able to kind of leverage all the existing work properly. Good. Yeah, Craig.
Well, there could be conflicts, right? That maybe it works okay on what you're doing, but it's going to conflict with something someone else is doing.
Good, right. So interactions with the rest of the code base, right? Either other code that's in this, in this repo, or sometimes how it interacts with, you're going to run this on Cosmosis or CCL or something, and it doesn't work properly when you do that. Maybe you can only find that out by checking it out and trying and my thing crashed because I did such and such. Exactly, right. So interactions with other code. Ideally, you can write unit tests to check that. Sometimes they're a little too unwieldy to put into your test suite. These are called integration tests or things like that. So if you can, you'll want, like if you identify a problem because of this, it's best if you can figure out a way to write a unit test that it, or an integration test that would have found it, something to put in your test suite. But that can be difficult, and sometimes you can only really do it by checking it out and running something in practice. Good. Other stuff? Phil? Great, yeah, so documentation errors. This is something that never touches the unit test. Unit test, we very rarely, I mean, you can, well, very rarely do you get unit tests to cover any documentation. But a human reading it can tell either there isn't any documentation here, or the documentation says the wrong thing, describes the wrong variables, lots of aspects to documentation. That's actually a big part of code review, is getting the docs appropriate. So good. More stuff? No, sorry, I'll get to you next. Right here.
Make sure it fits with the physical instrument.
How do you mean the physical instrument?
If you have an engineer on the team that understands a different section of the instrument than you do, make sure that all the parts of the code work together correctly for it.
Okay, good. Right. So if you're writing code, say for a particular modeling an LSST sensor, make sure that it works properly with the actual instrument that we have in the lab, say, right? So it connects to real devices correctly. Good. Yep. Rahul?
I was saying there is doctors which doesn't actually test the documentation, but it makes it somewhat easier to find that.
So doc test. I don't know about this, but okay. So doc test apparently is a tool to help make reviewing the documentation easier. Okay.
Or even for people coding up, it's easier to see that documentation was wrong.
I see. Okay, so easier to tell whether your documentation is accurate. Okay, good. Yeah, right here.
Reproducibility?
Like
For example, you have a code that works in a Mac and then you try to...
good. Okay, so that's called portability, but that's definitely good. So portability of your code. So I mentioned this a little bit before. Like sometimes your code will work on your laptop, but Travis it won't work. So yeah, so checking out and running code is one good feature that you can do as a developer, even if you aren't going to have time to review the rest of the code. Checking it out and running it, make sure the unit tests pass on your machine that maybe has an older version of NumPy or an older version of AstroPy or whatever, right? Sometimes these things have weird conflicts where particular versions matter. So in Galsym, we work on this a lot before we do a release. We ask kind of everybody that we can think of to try out the code and run the unit tests. We don't always try to be super complete on every pull request, but definitely at the release stage, we want to make sure we're as maximally portable as possible. So we try the code out on every system we can. So we run it at BNL, we run it at NERSC, we run it on different laptops with different OSs, all over the place, as many different ways as we can. Different compilers matter, all these kind of things. So that's definitely a part of code review. And if you can run it on your own machine, at least that gives you one extra data point. And so if there's big portability problems, sometimes you'll catch them right away. So that's good.
I think we can use the Docker image for that, portability thing.
To use what?
Docker.
Docker, yeah, sure. I mean, you can set up, Travis, to run a whole bunch of different varieties and use Docker to get different systems. That's true. Yep. Chris.
But the code is not covering the entire parameter space that you need. If you take it out and run it, you might find that putting in something other than just the inputs that they gave you might crash the code.
Good, right. So checking out the code works in parts of parameter space that maybe the developer didn't think of writing a test for. So we call these corner cases sometimes. So if you find some part of parameter space that's maybe particularly problematic, like your code has a transition at some particular value in parameter space where to the left of it, if it's smaller than some value, it uses one algorithm, and larger than that value, it uses a different algorithm. You definitely want to make sure you've remembered to check both sides of that line. And even close to that line should give you almost the same answer, things like that. Or if you're doing something with coordinates, you want to make sure that your code works properly when RA is right near 359 to 0. Like if your image crosses that plane and you're doing something with coordinates, you want to make sure it doesn't kind of think this is two images that are separated by 360 degrees, right? So corner cases. Are things that human reviewers are going to think of potentially, and that the unit test maybe haven't checked. So that's good. More ideas? All right. So I'll go through one more.
You mentioned Travis a couple times, and I don't know what that is.
Okay. So it's about unit tests. So Travis, I don't think I have a. Well, I can show you a little bit. It's a good question. The question is kind of, what is this Travis you speak of? Let me see. Let's go to the open one. That's probably better. All right. So this is good. So this is Josh's pull request on the von Karman profile, which, this is still all pending, I think. Cancel review. There we go. I don't want those. Okay. Good. So there's a number of checks here that we run automatically. So whenever you submit a pull request to Galsym, Galsym will send this off to helper places. One is Travis. So this is continuous integration, Travis CI, blah, blah, blah. We have coveralls, and we have 2 code covs. So if you look at, click here to details, it'll take you to the Travis page and show you we have 3 different runs. We test Galsym on Python 2.7, 3.4, and 3.5. And you can click through to one of these. And you can see this is the Travis log for when it ran. Let me just close this a little bit. There we go. So it shows you its log, and each of these things you can expand out if you want, right? There's some stuff there. But the main thing is here. This is where it installs Galsym. And then at the bottom, here, more installation stuff. So if you have an installation problem, it'll pop there. And then this is where it runs nose tests, where it's running our test suite. I guess there's a warning, which is fine. Ideally, we'd get rid of that, but we haven't yet. And then it collects a bunch of coverage stuff that it'll send off. The code cov stuff is from Travis running this. But if there was an error here, one of these dots would be either an E or an F. E means there was some error that got caught. F means there was a failure of a test, so some value came out wrong. And then it would come out as being as a failed a test run, and you can look and see what was failing here on Travis. When I run it on my laptop, it works, but you can see what went wrong here. And sometimes it's just numerical accuracy things. I mean, there's different hardware, so different rounding at the 16th decimal point. And if you write your unit test poorly, that can trigger a failure that you don't get on your own laptop, that kind of thing.
Is it a shell script or Python?
Yeah, kind of. So I can show you what that looks like too. The question is there a shell script or what? How does that get run? So you make this travis.yaml file, and you tell it kind of what branches to run on, what Python to run on. We used to run on 2.6 and 3.6, but we don't. This we could probably turn on again. I think they fixed the problem that we were having with it. But yeah, so it's not exactly a bash script, but these are kind of commands. So it does all these commands before install, and then this is the install stage, and then this is your test script. And then if it succeeds, you can run this extra stuff. So there's just different sections. So, yeah, and we have a template for LSST desk projects that already includes kind of a simple Travis thing that you can at least give you a starting point for using on your own projects. The question? No? Okay. All right. Back to here. All right, so you guys covered a lot of them. I'm going to go through the ideas I had. So one is missing tests, right? So your test script is great for whatever it does test. And as you guys pointed out, just because you have good unit tests doesn't mean you have all the right unit tests. So people, other developers can often identify tests that you forgot to include or didn't think about, stuff like that. So, check that it covers all the new parts of the code, make sure everything, so that coveralls can help that, or code cov, but humans can sometimes point things out to you there. Check the typical use case. Ironically, sometimes that can be forgotten. Like you might check kind of weird things, but just the way that a user is probably going to want to use your code is a nice way to check that things work, at least in that case. Check corner cases, really unusual parts of parameter space that are hard to cover, hard to remember to think of. Invalid user input. So if this is a user code, right, make sure that when the user does something stupid or wrong or didn't read the docs, it doesn't just completely. They gives them some informative error message and says, this is an invalid value. You can't have shears more than one. Blah blah blah. Whatever. So make sure there's appropriate regression tests if that's appropriate, or integration tests. And if it's a really complicated thing, a lot of times you may ask for validation scripts that aren't necessarily run as part of your test suite, but that you want kind of as an extra proof that when you run this in full-on mode, you get the right answer, and maybe compare it to some other calculation or whatever. So these are all kind of things that you can think of recommending to add. So here's an example of that in one of the Gaussian tests, Gaussian pull requests. So he had some regression tests. This is adding a new inclined exponential model of galaxies, and I just listed a few here that I said you should these additional tests. You should add these additional tests to your script. What you have here is a good start, but it's not sufficient. So the API, this is something that is very human centric, right? So the API has to be kind of user-friendly to people who are actually going to use the code, and so another developer is going to have a better idea of what works and what doesn't in terms of the API. So you might request some redesign of aspects to the API. So maybe in some very typical use case, you feel like this API is a little too clunky, like maybe you added a bunch of whole new features, but that means that the thing that most people are going to use now gets harder to use. So maybe you can push back on that. Or maybe there's a valid way to use it in the code that you think might be prone to misuse, right? So like the natural way, like if you have some scale parameter, right? Maybe scale is ambiguous about what scale you're talking about, and you're going to push back and say, well, I think that's probably, people might think you're talking about an overall flux scaling, whereas you mean the pixel scale, right, or whatever, that kind of thing. So if changing the API to be more specific sometimes, so that users won't do the wrong thing with it. If it's kind of inconsistent with other parts of the code, like maybe everywhere else you follow this one kind of pattern, and this new code has a different pattern, users are going to feel a little whiplash going from one to the other. So you might say, well, I think it should be changed to this style, change this parameter name, or change this functional form to match the other classes that do the same kind of a thing in this code base. You should sync them up better. If you're worried that they've kind of written out the possibility to add future changes that you're thinking you're going to want to do, right? So maybe this pull request doesn't include a bunch of code that or a bunch of features that you're going to need, and that's fine. But you want to make sure that the code is written in a way that someone can fairly directly add those features later, right? You don't want to kind of make it impossible or bake in too much of the existing, not including those features, right? So make sure it's extensible. And make sure that there's enough options. So make sure that if you have an idea of what some of the use cases are of this, make sure that there's a way for the user to do it. Even if it's kind of an edge case, that's kind of a, not the way most people are going to use it. It doesn't have to be necessarily super user-friendly to do kind of these odd things, but you want to make sure that they're possible and make sure that those options exist, even if they're not the standard. So these are all some ideas that people, as reviewers, can do. But obviously, it's hard to automate much of this. So here's an example. So this is some code that Josh added to this one. Good. So yeah, Josh redesigned a bunch of stuff, and he enabled this particular feature where he could expand with a function, which would then be a chromatic expansion, which is a nice feature. So without his new stuff, this was the syntax, which is a little bit longer, but I was concerned that this would be the kind of thing that somebody might misuse accidentally. They might accidentally be expanding chromatically and didn't mean to, and it would just transparently start doing a whole bunch of might be hard for the user to figure out what went wrong. So I expressed my concerns, and Josh decided that he agreed, so he reverted it, right? But it would be perfectly valid for him to have said, no, I think this is really important because of this, this, and this, right? This is that conversation that you have between the developer and the reviewer, and you always want to be kind of respectful, and just like a referee report, right? Trying to say, here are my concerns. You may have already thought about all this, so what do you think? Is this a problem or not? That kind of stuff. All right. Okay, so we already talked about this. This is the portability stuff. Sometimes the tests fail on specific systems, but not others. So this is a useful service. You can, the reviewer, even like I said, even if you don't have time to review the whole thing, you can try it out on your machine, make sure that your old version of NumPy doesn't fail when Travis is using the latest NumPy, and maybe the developer also has the latest NumPy, but your old system or whatever has something going wrong, or some old version of GCC, you get a compiler error. When everybody else compiles fine, your system doesn't. That's useful information, and you want to try to fix that as a team. Okay, move on from there. So here's an example. So Rachel's always really good. She checks out almost every pull request kind of right away and runs all the tests on her machine. So she has a couple machines where they have kind of some old versions of stuff, and so she often identifies weird problems that none of the rest of us caught, but we do want to fix. So that's a useful service. Okay, style. So we talked some about this. So definitely you want to make sure your code is clear. And the thing to keep in mind is the readability is paramount. So the readability is the most important aspect of style. Okay, so some particular prescription, fine. I mean, the goals of that of PEP 8, for instance, is to have readable code. But the very first rule of PEP 8, does anybody know the first rule of PEP 8? It's one of my. Excellent. Yes, Josh knows it. I probably told him too many times. So yes, a foolish consistency is the hobgoblin of little minds, which I love. And basically, if you don't know good style in Python, you should absolutely read PEP 8 because almost all their recommendations are excellent. But you also need to know when to break the rules to improve readability. There's times when if you just follow the rules of PEP 8, it's really confusing to see what where the commas are, say, because of the way they ask their to be. And so sometimes you just want to, don't put commas around the pluses, but do put commas around the colon, right? It would be the opposite of what PEP 8 recommends, but for particular circumstances, that can be a much more readable line of code, and so you want to know when to break the rules. So linters are good. Linters will tell you when you've broken PEP 8 rules, but really a code reviewer can say when that was a good reason to break PEP 8 rules. Another one that linters don't really get into, but it's in stuff like PEP 8 and Strastrup and these other style recommenders, is make sure the classes and functions are well named, right? So classes typically should be nouns, functions should be verbs, attributes can be either nouns or verbs, right, depending on what they are, right? So you can tell as a reviewer whether a function or a class is well named, and is it going to be easy to understand what code does when you're using that class, right? So if you say, sorry. So if you have like a function that's, let me try to think of a good example off the cuff. So if you say like, galaxy.redshift, right? So it does, as a function, right? Does that mean you're getting the current redshift of the galaxy, or is that the thing that you use to set the redshift of the galaxy? Or does that mean you're going to apply a redshift to the SED of the galaxy, like shift the whole thing, right? That's an ambiguous thing. Whereas you can add a verb to the front of that, and you can say galaxy.getRedshift, right? Would be a much better function name for the thing that gets the redshift. Or you could even use a property in Python to turn that, to not use the function at all, which is fine. Or you could say galaxy.applyRedshift. That would mean you're going to apply the redshift to the SED. Galaxy.setRedshift would be the thing that you would use to set the redshift of the galaxy. So having a verb as your function name, potentially with a noun after it or whatever, is a much more readable style. So that's something that you want to be looking through as a code reviewer. Make sure that all the names of things are. If someone's is just kind of violating PEP8 all over the place, I don't recommend doing line by line, PEP8, put a comma here, PEP8, remove these spaces. Just if it's really bad, run this through a linter, use PyLint on this, change most of them, and that's a better recommendation. But and if your team wants, you can automate that. Like I said, I pushed back. Josh tried to get us to do that, and I pushed back because I found there were too many places where it suggested what I thought was unreadable, or not unreadable, but worse style code. And then if something in particular is really hard, you can suggest specific style changes if you think something is really hard to read. So here's just an example. I think Aaron submitted some stuff, and he added a new class where he called something HLR for the half-light radius. And in other classes in Gaussian, we tend to spell that out as half-light radius rather than use the abbreviation. And so I just, to be consistent with the rest of our style, we changed it. It wasn't necessarily wrong on its own. If this was code that existed all by itself, it would be fine. But within the context of it being a Gaussian class, should be changed. So that's the kind of thing you're looking for. Documentation, we talked about this some already. So this is something the user is going to be interacting with a lot. So a reviewer can put themselves in the role of a user sometimes a lot more easily than the original developer can. So they can read through the documentation and find out when things are not well explained, like it doesn't include a good description of the new feature, it doesn't include guidance on what kind of parameter values to use, things like that. We have a change log for the changes between versions. So a lot of times, there's another service that Rachel's very good at remembering, is finding out that we forgot to add the new change to the change documentation edit. Aside from the user documentation, there's also internal documentation that's, I think, equally important to have good comments there. And so these are the comment lines that appear in your code describing what you're going to do. So for instance, if you're implementing, Dodelson-All, equation 7, you should write a little comment saying this comes from Dodelson et al. 1998, equation 7, right? Whatever. Give a reference to the paper. So people who don't really follow what you're doing, like why are you doing these calculations, they can say, oh, well, I can go back to that paper, read it, and understand where this is coming from, why that's the appropriate formula to use. Or if it's some algorithm, you might reference a Wikipedia page where they describe it or whatever, right? Describing providing some external reference is good. If it's something that you did yourself, like a lot of times you'll just do a little bit of math to figure out some calculation. Write out the math. It's 3 or 4 lines sometimes. Will help a lot the reviewer to understand what's going on. And in particular, if that line ends up being buggy down the line, you don't want somebody else to have to redo your 2 hours of struggling with some algebra. Give a few steps so that they have a good guide of what they're supposed to be doing to derive that is helpful. Good. So if you use like Sphinx or some automatic documentation renderer, that can be a useful thing to do, is to try that out. Probably it's only really relevant at the very end before a release to make sure things render properly, but that's something you can do during PRs especially if you see something that looks like the Sphinx style wasn't quite right, you can try it out and see how it renders and say, oh, I don't think this is going to work out right. It's not going to show up as an equation. It's going to show up as a block or whatever. And if it's appropriate, so we also have some tutorials and demos. Also, if you think a new feature should be put into a demo, it's a good thing for a reviewer to recommend. So here's an example where Rachel says, I think this should be more explicit now that these instructions are not. Edit that up, and Josh rewrote parts of the documentation to describe his new feature. So, and so this is where the response comes in the inline comments. So inefficiency. So I put this last because it's kind of the least important thing most of the time. But you do want, so you always, there's a rule, like don't prematurely optimize. Don't optimize before you know you need to. And that's absolutely good advice. But the flip side of that, you also don't prematurely disoptimize. Don't use noticeably inefficient code. Sometimes the efficient code is just as easy to read as the inefficient code, and so you should just switch to the efficient code. So in Python, if you have a for loop that's just looping over things and appending to a list, make a list comprehension, right? If you have some calculation that's a constant, but it's in the inside of a loop, pull it outside the loop, right? So there's just kind of some very basic efficiency things that are appropriate to put in to comments in review. But don't spend too much time on that. So you don't want to really try to write a super efficient code when you don't even necessarily know that this is going to be a tall pole for the running time. It's just a waste of time to do that then. If you do have some new algorithm, some more efficient way of doing something, a better algorithm, a lot of times it's a good idea to keep the old inefficient way of doing it as a unit test. So you want to compare that your inefficient code matches your efficient code. So that's a kind of aside, but it's a good thing to kind of keep that as a test. Another thing that sometimes you can notice as a reviewer, like maybe you'll realize you're seeing the same piece of code multiple times, maybe with very small tweaks, maybe not even with any tweaks. And that's a sign that, well, maybe that step there maybe that should be pulled out into a helper function, just for code reusability and code extensibility. That's a good idea to recommend. So why don't you pull that out and make that a utility that we can use multiple places. So here's an example of me giving a suggestion to Josh about an algorithm. So I did a little test that this code was suspicious that inefficient, so I a different way and checked to see how much it probably violates my premature optimization thing. So I put it in as a suggestion, and Josh decided to take it, so that was nice. But that's probably the most kind of complicatedness that you would ever want to do in a efficiency. Okay, questions about all that? Yeah.
So you mentioned this example of if I add an attribute, what would you have
If I, sorry. What?
just had redshift as an attribute?
Oh, so an attribute is fine. So galaxy.redshift, so as an attribute, a noun is perfect. And get that value. So pixel scale means what's the pixel scale of the image. But as a function, so if it was redshift as a function, that is ambiguous. So there you want to have the verb. So get redshift, set redshift, apply redshift, whatever. So you always want, it's a function, that's when you want to have a verb as your first bit. Almost always. I mean, there's probably exceptions, but that's, you want to think hard if you're realizing you're writing a function that's not starting, where the name doesn't start with a verb. That can be very confusing. Yep, Jim? You mean like contribute? Absolutely, right. So in Nelson, we're fine with that model. There's lots of times when, as a reviewer, you say, I changed this. Let me know if you have a problem with it, but I think this would be a lot better this way. And so and you've just contributed commits yourself. We do that pretty regularly. Yeah, so I don't think there's necessarily a problem with reviewers adding code themselves. It probably depends on the culture of the group. Like I could imagine there being groups where people would feel their toes are being stepped on with that kind of a model. So you want to know all pretty friendly, so none of us ever, especially, so typos, even mention them. Like if you notice a typo, it's just quicker to change it and commit it than to say, you misspelled blah here. It's not even worth a comment. Other comments? All right. All right, so now we know what you're looking for. So who should be doing these reviews? Not really a trick question, but what do you think? So you have a team of people and somebody submits some code. Like who should do the review? Okay, good, right? So not the person who wrote the code, right? So self-review is not really very helpful. That's a good point. Excellent. Anyone else? Jim should do it. Jim should. That's not wrong. So getting some expert to review code is not a bad idea. So we as a, obviously Jim can't review everybody's code in Desk. But it's not a bad idea to ask somebody who you think would be a good code reviewer who's outside your team to review some code from time to time. So this is something that the architects, the Desk architects have volunteered. So Jim's one, I'm one, there's a few others. And I think you'll hear more about it tomorrow. I think Phil's going to announce, or somebody. Phil, somebody's going to announce it, yeah.
Following up on that, I mean,
yeah.
maybe this is something we'll hear more tomorrow, but for papers, right, you have this internal review process that also sort of goes outside the direct contributors to
Right.
the process. Is there a collaboration plan to establish pools of code?
No. So the closest we'll get to that is probably from time to time we'll have teams of people review code, especially kind of before releases. You'll want people to look at the overall code base. Things that are going to be used, like the analysis code for DC2. When the team who's working on some bit of that thinks it's ready, they can announce it, and we'll get kind of multiple people code reviewing from different points outside of the team. So that's I think we don't have a formal plan, as far as I know, to structure that, but it's definitely a good idea, and teams should absolutely consider, when you think you have some code ready that you want people like Jim or myself, or Alex is also on the team of architects. So if you want somebody outside to look at your code at particular points in the process, that's a good idea. So what about just a regular, you guys are developing like CCL, somebody code to CCL and submits a pull request. Who should be doing that review? Idea? No? Yep, Erica? Okay, someone who's familiar with the code that's it's being contributed to, right? So somebody who's on the team who's already contributed some code to this base, maybe somebody who wrote the code that's being added to, like usually these are kind of a new feature on part of some code. So like in Galsim, if you were to contribute something with the chromatic stuff, we'd almost certainly ask Josh to be a reviewer of that because he wrote the first pass of all that code, and probably 90% of everything that's in there is from him. So if you're adding to that, he's got the guy that knows all the implications of where else that might touch, what could this break, these kinds of things. So somebody who's familiar with the code is definitely an important person to get to review it. Good. Anything else? Good, right. So you might, if you're implementing some physics process, you might ask somebody who knows kind of the thing that you're trying to model, and might, when they run it, might be able to say, oh, that doesn't look anything like what it's supposed to look like. So some expert in the kind of niche field that you're trying to implement in the code. Excellent. Yep. Yeah.
Well, wouldn't it also make sense to have somebody who actually doesn't know much of the field to review it? Because for them, if they can't understand it, you have another problem there.
good, right. So somebody who's not necessarily versed is also a good reviewer, especially for the parts that, like understanding the documentation. So if they can't understand what this code is supposed to do from reading the docs, that means the docs are not sufficient. Right? So maybe they can't understand the code part well enough, but they, a lot of parts of the review that would be excellent for us to take a look at. So that's definitely a good point. Yep. Potential user, excellent, right. So somebody who's going to use the code and isn't a developer is an excellent person to, a lot of times for the API, knowing what this feels like the kind of way I want to use the code, can I understand the documentation, all that kind of stuff is excellent. We definitely want users to regularly review code. Good. All right, I think that's most of the things that I came up with. So let's see. So our rule is ideally 2 other developers who are in the team of the project. That, I mean, obviously this can vary from group to group, but that's a good rule of thumb. You get at least 1, obviously, but preferably 2 different people to kind of look at the code and make sure that things are okay, who are developers. And in particular, like I said, somebody who's already worked on portions of the code, definitely include them. We also want to encourage junior developers, and not necessarily just the senior people on the team, but junior people. Partly they can kind of take the role of a non-expert, or take the role of, like maybe they're not as familiar with the code base, but they know how they would want to use the code if they're just getting started. Also, it's useful for them to look at other people's code. Is a great way to learn how to improve your own code, is looking at how other people solve the problem. So if you're a junior developer and you have an opportunity to do a code review, I would recommend the first thing you do is say, how would I solve? What kind of code would I write? What should I, what kind of algorithm would I use to do this? What kind of design of the API would I do? Kind of think about it yourself before you even click through to see what the code is, and have an idea in your head of what would you do as a developer, and then look through and see. And maybe you'll say, oh, wow, that's way better. Or maybe you'll say, hey, I figured it out. This is basically what I would have written. Or you might say, I think this could be done a lot better with this other way. I mean, just because you're junior doesn't mean you're not smart, obviously. I mean, you're all super smart people. So you can come up with ideas that the more senior people on the team didn't think of, because maybe they haven't taken coding classes in 20 years, and so they don't know some new trick that you learned 2 years ago in your CS class, whatever, right? So definitely want junior people to kind of contribute for both reasons, for their own learning and for contributing their ideas. Super important. Like you said, users of the code are excellent, especially for the API design and the documentation. And sometimes bringing in the outside expertise is definitely a good part of it. So I think you guys pretty much got all of them. All right. So I was going to have you guys discuss in groups. I think we're running a little low on time. So maybe I'll just for ideas from the audience on this one. So what are some things you can do to make it easier for the reviewer? So we don't want to put too much burden on these reviewers. So what can you do? Yeah.
Provide instructions of what portions you want to have with that.
Okay. Well, so the portion, so you have a whole bunch of new code that GitHub's already going to tell you what the new stuff is, but provide kind of instructions on give some idea of what the changes are, right? Good. What else? No? What else can you do? Yeah. Sorry? Good documentation. So make sure that your documentation is ready, because that's going to be a first place the reviewer is going to go. Before they look at the code, they're going to read the documentation so they know what they're looking at. So definitely, yep. Have modular code. So keep it contained into smaller modules, so you're not kind of sprawling, covering everything, right? Good. Melanie? Good. So as a group, you can have a checklist of things that you should always do when you're preparing it. So make sure, did you run it on a couple machines? Did you add your stuff to the changelog? Did this, right? So having a checklist of things to go through is helpful. Good. Other ideas? Yeah. Good. So you can suggest having a phone call where you say, you know, or you know, Skype call or that kind of thing, where you say, I'll go through and give my take on what the changes are, and then that'll help a reviewer kind of get going. So that's definitely a good idea. Others? Yeah, Craig.
A usage example.
Give some examples of how the code should be used. Right. Good. Yep. Definitely. Robert. Right. Yes. So discuss with your potential reviewers what your changes are, either before you write the code or as you're going, as you run into problems. Have the conversations before you're done and before you're ready to have the review. Absolutely. What was the first point? Just like for a bug fix, it's.
Well, smaller things are different, right? For a small thing, you say, here's my change set, look at it.
Right. Okay.
You have a long conversation with Will and I.
Good. Right. So yeah. So if it's a small change, so when you have a bunch of change, don't have lots of bug fixes in one pull request. If you have just a bug fix, make that a single pull request and just do it. And that's quick. Good. Okay. Any more? All right. So the first one is if you can keep it short. So this is keep it like in a modular, or if it's just a bug change. Those are very helpful. So if it can cover just a single topic, that's ideal. Usually you want your reviewer to be able to kind of understand and get through the code in just an hour, 2 hours, that kind of level. So if you are too sprawling in your coverage of what you're changing, that's going to be really hard for the reviewer, because they'll have to go and have lunch and maybe go to sleep, and then they'll be back and they'll have forgotten all the things that they'd already thought of. So you want it to be at least possible for them to do it in one sitting, of getting through and understand what your code changes are. Bug fixes especially, could be 5 minutes to do a review sometimes if it's short enough. Sometimes you can't really do that. So if it's a really large refactoring where you're changing, you're touching the whole code just because you're changing how some parts of it work. So I've had a few of these in Galsum, and they're kind of a reviewer's nightmare. So I've broken the keep it short rule too many times, I'm sure. And so if you break it up into several smaller chunks, that can be helpful. Even if in your head, it's kind of all one project and it's all one change, the refactoring it. If you can kind of do it in stages where you get back to working code, piecemeal to the change you actually want to get, that helps. And then for really trivial changes, depending on your group, but especially if you're kind of if you're only in the 0.x release stage where you're kind of actively working. If it's a trivial change, like you try it on ICC and ICC has some error and you realize it's just a quick fix, maybe you don't even bother with a pull request for that. Maybe you just push that to master. So you want to be careful with these kinds of things, but sometimes if you think it's not worth bothering people to do a review, depending on the group, that can be okay. So here's an example. So when you make your commit, so this is somebody who added a feature to Galsum of adding supporting unsigned integer images, which we didn't used to support, now we do. And so you can see this number in the upper right here is how many lines of code are affected. So he added 212 lines of code and removed 91. So really that means probably 91 lines were changed and there's 100 and whatever new lines. So that gives you a feel for kind of how big the pull request is. So if those start getting more than 1,000, that's when I would say it's getting a little unwieldy. I've had plenty that are 5,000 or 6,000, and they're harder for reviewers to find the time to do. They're a bigger job. So if you can keep that short, that makes the reviewer's life a lot easier. So you can provide a summary. So some people touched on this. So in that initial comment, if you can kind of lay out what are the important things that the reviewer is going to want to be looking at, you know what they're going to see, and you can say, okay, you're going to see a bunch of things that look like this. That's because I wanted to do this other thing, get rid of this feature and change it to this feature, whatever, right? You can explain kind of what they're about to be looking at when they're going through the code. So it gives them context. You can especially anticipate the corner cases. So we talked about there being tricky corner cases sometimes. tell them, you're going to see this weird thing here, and that's because it doesn't work otherwise when we get to this part of parameter space. And at this part of parameter space, you have to switch over to this other algorithm, otherwise the errors blow up, whatever. If you had some kind of tricky API decision, maybe present it and say, I went this way with this API, but I was also considering this other one. Let me know if you have there's an advantage to one or the other. Kind of lay that out in advance so that you give them an easier option to kind of make suggestions then. If you have, usually a pull request is connected to an issue page, but that's typical. Make sure you reference that page in your comments. So this pull request for issue blah, right? And GitHub will automatically make a link for you, so it's easy. And especially if there's any discussion there that's relevant, that's helpful. And one thing which I don't often do, but some people have recommended this, which I think is a clever idea, is right after you hit submit on your pull request, you can go through yourself and add line comments. So you can say, go to some particular function and add a line comment right there and say, this algorithm is coming from this, and I just thought about this, this, and this, right? So the reviewers, when they get to that bit of code, they'll see your comment about that line of code. So I've never really done that, but I think it's a pretty interesting idea. Sorry, what? Well, it could be, right? And well, so I do recommend putting extensive code comments. I've already recommended that, right? But like an API decision, right? So I was considering these two APIs, and I decided to go with this one, but let me know. We can switch it to this other one, right? You can put that. That doesn't belong in the code.
Point out tricky corner cases you considered. Discussing the algorithmic decisions you struggle with.
Right.
I would really want to see in code that lived in Git forever.
Sure.
Things like, I could have spelt this differently. Do you want it spelled in American or whether that's wrong? Sure, you can put that in the comments. I mean, they seem to be you're mixing very different things with this.
I don't think so. Well, so I think some of these do belong in the code, but I think they also belong in that comment at the start. I think you want to give a summary so that the reviewer doesn't have to go through and find your inline comment that's particularly appropriate to this thing. Give them an advance warning saying, there's a bunch of things that look like this. Here's why I went that way. And then, algorithmic decisions, if you don't necessarily have an inline comment that says all the algorithms that you didn't use, right? You want to I would only describe the algorithm that you did use, right? Okay. But anyway, some of this can be inline comments, and I recommend extensive inline comments just in general. So a lot of this could also be in inline comments. That's certainly a true statement. So here's an example. So one that you can see is not one of my smaller 5,000 plus and 5,000 minus. So it's changing a bunch of stuff, but a lot of it was fairly trivial. And so it's changing a lot of boost shared pointer to standard shared pointer. So there's a lot of lines of code that are just a trivial change. So it's not, most of those lines are not hard for the reviewer. Let me break out of this. Good. This one? This one. Right, so we changed a bunch of things. Like I said, why some of those things should be changed, and I rewrote this in Python, so you'll see that, right? And some implementation notes, why some features were the way. An extensive comment, I think, is very helpful to the reviewers. Robert's comments notwithstanding. Okay, and this is one that Robert suggested. So discuss your work while you're developing or before you develop. This is important. So don't wait until the code review to get feedback, right? So definitely, so GitHub issues make this very easy. So you can, as you're going, say, I ran into this weird thing. I'm getting, anybody have ideas about that? Mention certain people that you think can give you good feedback. Especially as you get kind of good validation results, advertising that is useful. And then these would be good people to assign as reviewers. People who participate in these discussions are already fairly familiar with your code. They would be good choices to assign as reviewers, sort of obviously, I guess. So here's, let me actually break out of this and we can show this live. Oops, where is my cursor? There we go. So here's one. So for Josh has realistic atmospheres, and he references this issue, 549, where we're waiting for GitHub. I should have preloaded that one too. Oh well. Right. So there's a whole bunch of code here, and he produces as he's going. He says, here's what I'm getting so far. This looks really cool, right? And then we go along some more. There's people commenting. I found that bug that was preventing multiple layers. Here's the new version. So this kind of gets people interested. Like, wow, this is really cool. And when the pull request finally comes out, you're much more interested in actually looking at that code because you've seen these cool videos of phase screens flying around and PSFs being constructed, right? So this is a really useful way to kind of get feedback as you're going and to generate interest in the code that you're working on, because lots of people are interested in these kind of results. So, okay. Okay, so conclusion. So developing as a team requires a little bit different way of thinking, a little bit different workflow than when you're just writing code for yourself. So the code review, I think, is an important component of this kind of collaborative code development. In the long run, like I said, code reviews save time. They're not a time suck. They are, in the long run, invaluable for getting good quality code. And it'll also improve your ability as a coder, right? You'll be a better coder if you look at lots of other people's choices, especially if you have a chance to, if you review some of Robert Lupton's pull requests, like you'll learn a lot of great coding techniques, right? He's a great coder, and you'll learn a lot from just looking through his code, thinking about how he did things, what were his design choices. That's an invaluable way to become a better coder yourself. We have, for further reading and recommendations, we have this LSST desk coding guidelines where we've tried to encapsulate more so than just the code reviews, but unit tests and documentation, lots of things there, which is now live, I think, in the sense that it's now an official desk note. So I recommend you guys reading through this. I think there's a lot of good ideas here. I'm not going to scroll through it all the way now, but there's kind of different guidelines for style, coding choices. If you feel like you're a little bit overwhelmed with some of the, how to write good code for a desk, this should have a lot of good information for getting on that. Okay, that's it. Any other questions? Nothing? Right.
So like most pull requests, you would go through the deck and check that that was correct and show you all the lines and changes. But like with a pull request like that, part of the thing would also be like checking the existing code because it's implicit do that. Is there sort of an efficient way to like look for that kind of error?
Sorry, I didn't follow. Is there a way to check for what kind of error?
So like if you're making a change where you wanted to change all the boost planners, standpointers, then a potential error would not just be in the quick changes you made, but in when you forgot something.
I see, right. So the question is there a way to check that things like that are inclusive? Like you've remembered all of the places where there's a standard pointer switching to a standard pointer, or standard short pointer. The only one I know, the one that I used when I was doing it, is grep. So I would just grep boost : shared star.cpp and see what popped and just make sure I changed everything. I don't know of a tool for doing that kind of thing. I mean, eventually it would become an error because we're getting rid of the boost include lines as part of this. So I think this one did eventually show up. It would have showed up as an error because you're no longer including boost, so it would be a compile error. But other than things like that, I don't have a particular recommendation. Just a guideline to help make it easier, though, is part of the reason you want sort of verbose variable names. So if you're using variable names of D, or hue, right? Those are a lot harder to grep for than, you know, galaxy shape or pixel scale, right? So, like H, you know, you Hubble constant, you know, it sounds verbose, but you know, H is a lot harder to grep for. You know, even H0 would be helpful. Other comments? Yeah.
So you know, Travis saying, is there going to be a recommended route to hooking code with Travis or similar?
Yeah, so Jim Chang made so this is referenced in this document actually. Let's see if I can find it real quick. Here we go, tests. Oh, I guess I didn't link to it. Yeah, I think I mentioned it in here somewhere, but apparently I didn't make a hyperlink. I should have. I should go back and do that now. But yeah, so what'd you say? It's called something template? So yeah, so package template in the LSST desk. It's one of the, it's a repo that you can start with, and it's got the .travis XML or YML file. It's got it's got a setup.py. It's got some kind of basic things to kind of get. Right. And what I would recommend is just look at things that you think do similar stuff. Say, what do their Travis.yml files look like? And yeah, I mean, if you Google around, just the very basic getting started with Travis is, yeah, you'll find that online. But then once you're kind of writing your own Travis file, I looked a lot at kind of what other, you know, what does SciPy do in their Travis file? What does, you know, AstroPy do in their, things like that. It's just really helpful to look at examples and copy the bits that are relevant for your project.
I mean, I think the tricky thing is if you, for example, want to write something with Travis that uses the full LSST stack or the SIM stack, you know, the Travis has to have an image where it has that software in it.
Right.
So people like Heather have been working on making Docker images that you can attach to Travis, which would have the software in it. But if you write some code that's using, you know, IMSIM or something, which is using simulation plus DM, Travis has to have all of that installed. So getting that set up is a little more work.
Right. So if you are doing that, looking at the IMSIMS Travis file is a good place to kind of copy over the relevant bits to your own.
Recently updated that one to use some Docker.
So yeah. More comments? Okay. Oh, over here.
I was just wondering
If there's a what?
a link to
So I don't think it's linked to Confluence anywhere. Phil, maybe, is this linked anywhere official yet?
Yeah, it's the most recent row in the interim paper tracker conference page.
Oh, that's right. There's a list of desk notes, which is on Confluence, and yes, so this is on that page. Good, thank you for reminding me.
Might be good in the, you know, getting started area. Like there's a section of, you know, how to blah, blah, blah. So you get the
Anything? Good? All right, thank you, everybody.
So